Okay, welcome to topic 7. This is the last topic in the Mathematics 1101 course, and this is on matrices. A lot of what you're going to be doing in this topic depends on your calculator. Make sure you have a calculator that can do matrix calculations. The TI-84 definitely does matrix calculations, and also there's a Casio model as well that you can use for matrix calculations. You're going to be doing mostly that with your calculator. So we'll start out by looking at some basic definitions and some basic operations. Scalar multiplication, determinants of a matrix. Actually, you did determinants of a matrix back in Math 1700 with your calculator, and you'll be doing a lot of that with your calculator as well. Okay, so let's get started right here. Definitions and basic operations. Basically, a matrix is just an array of numbers in some kind of a rectangular form. They could be square, or they could have more columns than they have rows, and vice versa. Notice the difference between a matrix and a determinant. For example, this is a determinant. This was what you were using your calculator to evaluate in Math 1700. A matrix looks very similar, but you'll notice the brackets are not just straight lines. They are actually square brackets on this. Back when I was in university doing matrices, we actually used rounded brackets like this to do our work with matrices. So if you ever see me write rounded brackets for a matrix, remember it means basically the same thing. Each number in a matrix is called its element. So for example, this matrix they show right here, that matrix has 4 elements into it. The dimensions of a matrix basically refer to the number of rows and the number of columns. When you're talking about the dimensions, when you give the dimensions, we write it with the number of rows first. So for example, this matrix that they show here has 4 rows, 1, 2, 3, 4, and it has 3 columns, 1, 2, 3. So we say that this matrix has a size 4 by 3. That's its dimensions. The 4 comes first because the number of rows come first. If your matrix has exactly the same number of rows and columns, then it's obviously called a square matrix because it looks like a square. This matrix given, for example, here has 3 rows and 3 columns, so its dimensions or its size, we would refer to this as a 3 by 3 matrix. Okay. One thing you need to note is that determinants can only be calculated for square matrices. Even back in Math 1700, that's the only determinants that you actually calculated. A couple of interesting matrices, one more interesting than the other. This matrix right here that has all zeros in it is called the zero matrix, or sometimes it's called the null matrix. Another matrix, and this one is more useful, this is called the identity matrix, right there. The identity matrix, if you look carefully, it has to be a square matrix, and it's basically composed of all zeros except for down this, what we call the main diagonal, or the major diagonal, from the top left to the bottom right. That's all ones. Everything else is a 0. So this is what we call the identity matrix. And this actually plays a part. It plays a role in some of the calculations that we'll be doing in this unit right here. And as another note, matrices are named using capital letters. The null matrix is referred to by the letter 0, O, and the identity matrix is referred to by the capital letter I. All right, so that's called the identity matrix. You're going to see that again before this is over. Okay, a very simple thing that you can do with any matrix, and it doesn't have to be a square matrix, something called scalar multiplication. And basically it just means that you can take a matrix. Here we have a matrix A. If you were to multiply that matrix by a scalar such as 5, all it means is that you would multiply every element in matrix A by the number 5. So, for example, 5A would be equal to, well, just take each one of these elements in this matrix A, multiply it by 5, and you would end up with, well, 3 times 5 is 15. 9 times 5, 45. And 4 times 5 is 20. And negative 2 times 5 would give you negative 10. So that's what we mean by scalar multiplication. It's actually pretty straightforward, very simple. This practice number 1, this is on page 3. I'm going to leave this one for you to try. It's basically the same as the one we just did. It's just scalar multiplication. Now, even if you have a fraction in front, it's the same thing. You just multiply through by that fraction. You can leave your answers as fractions if you like, or you can change them into decimals. Fractions are usually more exact, but it's up to yourself how you do that. The determinants of a matrix. Now this is something that you calculated back in Math 1700 as one method that you used to solve a system of linear equations. You may remember something called Cramer's rule. Well, that's where you use determinants. Here's the symbol for the determinant of a matrix. If you have the matrix shown, then you just write DET in front, and that's what is referred to as its determinant. In fact, that's the symbol on your calculator. If you look carefully, if you have a matrix typed into your calculator, you can find its determinant by looking for the DET command. And of course, the determinant of the matrix here is how it is written using the determinant notation, the two straight lines on the side. And to evaluate a 2 by 2 determinant is actually pretty straightforward. You multiply together the elements in the top left by the bottom right, so that would be 4 multiplied by 3 as shown here. And then you subtract, it's always subtract, the elements in the top right multiplied by the bottom left. So that would be 5 multiplied by negative 1. So 4 multiplied by 3 gives you 12. And this would be subtract negative 5, which turns into plus 5. And so the answer here is 17. It's actually easier to just manually multiply the elements together to find the determinant of a 2 by 2 matrix than it is to type it into your calculator. It would take you much longer to do that. Okay. Now, anything bigger than a 2 by 2 determinant, it can get pretty complicated to actually multiply those together. So in those cases, you're better off using your calculator. Now, unfortunately, the Casio apparently can only handle a maximum size of 3 by 3, a 3 by 3 matrix or a 3 by 3 determinant. So some of these calculations you would not be able to do on a Casio. And by the way, in the back of your notes, please note Appendix A, which shows you how you can use your calculator to evaluate determinants and to also multiply matrices together. So please have a look at that when you get an opportunity. These practice questions here, we'll leave these for you to try. I think I'd just multiply out A. You could use your calculator if you like. B, I would definitely use the calculator. C, well, if you don't have a Texas Instrument TI-84, you won't be able to do that one anyway. But definitely use your calculator if you have the Texas Instrument. If not, well, just leave that one out because you won't get one that large anyway on any kind of a test or quiz in this course. And then in part D, what does part D say? We have a determinant that's equal to 12. You can actually turn this into an equation. So again, if you multiply your determinant together, you evaluate your determinant. The 7 multiplies by 4. So 7 multiplies by 4. Subtract. And then the other two elements would be 2t multiplied by t. And now the answer, you know what this determinant evaluates to. It actually evaluates to 12. We can turn this into an equation. So you're going to have 28 minus 2t squared is equal to 12. And now you go ahead and you try to solve this equation for t. It's quadratic, of course. So let me see. If you bring your 12 over to the left and bring your negative 2t squared to the right, you're going to have 28 minus 12 is equal to positive 2t squared. So that's going to give you 16 is equal to 2t squared. Let me come up here and finish the calculation. Divide both sides by 2, of course. you're going to have t squared is equal to 8. Now, what would you do there to get t by itself? Well, you take the square root of both sides. So t would be equal to, now don't forget your positive and negative. There's two solutions to this quadratic equation. Positive or negative root 8, which you could also simplify into positive or negative 2 root 2. So that's how you would use this determinant equation and calculate what the value of t is. It's actually very straightforward, not that difficult at all. Page 5, we have some basic properties of matrices. The commutative law for addition holds with matrices. In other words, if you can add matrix A and B together, they'd have to be exactly the same size, by the way, the same dimensions, then the order does not matter. The associative law for addition is also true. By the way, what's interesting is that the commutative law is not true for multiplication for matrices. In general, it's not. The distributive law holds for matrices. And also, if you take any matrix and add to it the null matrix, assuming it's the same size, then you end up again with matrix A. It operates like the 0 does in regular numbers, regular integers. In fact, if you take any number and add 0, you get that same number back. And for question number 1 right here, evaluate each of the following using matrices A and B below. Now, you will notice that example A is just another example of scalar multiplication. So you can take matrix B and multiply that by 3. No problem. You just multiply all of the elements by 3. And also for part B, it says take matrix A and multiply it by 2. Now, when you do so, the matrices 3B and the matrices 2A, they're going to be the same size. They're both going to be 3 by 3. And therefore, you can then subtract one of those matrices from the other. They have to be exactly the same size to add or subtract. So let's just quickly have a look at this one. 3b, so just multiply everything in matrix B by 3. You're going to get 9 and 6 and 12. This pen is not very good. Negative 15, and 9 times 3 is 27. And negative 2 times 3 is negative 6. And then 8 times 3 is 24. And 0 times 3, well, that's still 0. And then we have 3 times 3, you get a 9. So there's your answer for A. And now for B, for 2A, multiply everything in the matrix A by 2, you will get 6. 2 2s are 4, 7 2s are 14. And you'll have 4, and you'll have negative 10, and 8, and 2, and 0, and 16. Now you'll notice that part C asks you to subtract one from the other. So here's matrix 2A right here. I'll just leave that there. There's 2A. Now we're going to subtract matrix B. So I'll just write that behind it here. 6, 12. Oops, I'm running out of time. Negative 15, 27, negative 6, and 24, 0, and 9. So if you wanted to, you could even subtract these with your calculator, but it's pretty straightforward. What you're going to have now is 6, this element right here, subtract this element right there is 9. So that's going to be negative 3, and you just continue with this. 4 subtract 6 is negative 2. And 2 subtract 12 is negative 10. There's your first column. That's your first column there. 4 subtract negative 15 is the same as 4 plus 15, so that's going to become 19. And negative 10 subtract 27 is negative 37. Actually pretty straightforward. 0 subtract negative 6 is positive 6. 14 subtract 24, negative 10, I do believe. And then 8 subtract nothing is 8. And 16 subtract 9 will give you 7, and there is your result. You can do part B on your own. Use a calculator to evaluate the determinant of matrix A and matrix B. And for question number 3 on the bottom, I'll tell you what, I'm actually going to make a video part 2 on this, all right? So that I can go over how these problems here are done, because this video is almost up. Okay, so I'll see you again in just a moment.